For today's video, let us answer the set of questions in the difficult round in the Metrobank MTAP Math Challenge 2019 Division Orals for Grade 9, and I hope you will learn from this video. On number 1, simplify x over x plus 2 plus x over x squared minus 4 all over 1 over x minus 2 plus 1. So let us write first the given. So let us have x over x plus 2 plus x over x squared minus 4 all over 1 over x minus 2 plus 1. So let us simplify first the numerator. So the LCM of x plus 2 and x squared minus 4, that is x squared minus 4. And then x squared minus 4 divided by x plus 2, that is x minus 2, and then multiply by x, and then let us write x, and then on the denominator let us have x minus 2 on the denominator, x minus 2 divided by itself, multiply by 1, that is 1, and then x minus 2 multiply by 1, that is x minus 2. So let us simplify. Let us have here x times x is x squared, and then negative 2 times x, that is negative 2x, plus x over x squared minus 4 all over 1 minus 2, that is negative 1. So we have x minus 1 over x minus 2. So let us simplify. Let us multiply this one. So we have now x squared and then negative 2x plus x, that is negative x, multiplied by x minus 2 over x squared minus 4 times x minus 1. Then let us factor this one. So this will be x times x minus 1 times x minus 2, and then x squared minus 4 can be written as x plus 2 and x minus 2 times x minus 1. And then to simplify our answer, let us cancel x minus 2 and x minus 1. So therefore, our answer is x over x plus 2. So this will be our answer. On number 2, each side of equilateral triangle ABC has length 6. Let D be the midpoint of BC and E the point on AD so that BE bisect angle B. Find the perimeter of triangle ABE. So to find the perimeter of triangle ABE, let us illustrate first the given. So let us have an equilateral triangle A, B, and C. So D is the midpoint of BC and E the point on AD so that BE bisect angle B. And the measure of each side is 6. So this one is 6. So this is 3 because D is the midpoint of BC. And we all know that equilateral triangle is equiangular triangle. So that means the measure of each angle is 60 degrees. So this one is 60 degrees, this one is 30, 30, 30, and this one is 60 because this one is right angle. So let me separate the two triangles in order for us to find the perimeter of triangle ABE. So let us have triangle EDB. So this one is 30 degrees, this one is 60 degrees, and this one is 90 degrees. And let me have triangle ADC. So this is 60 degrees, 30 degrees, and 90 degrees. So as you can see, we have a special right triangle 30, 60, and 90. So the opposite of 30 degrees is A, and the opposite of 60 degrees is B, and the opposite of 90 degrees is C. So this one is A, B, and C. So the measure of this side, that is 3. And the measure of AC, that is 6. So let us have the value of A. So B equals A square root of 3. The value of side B, that is 3, equals A square root of 3. So divide both sides by square root of 3. Let us cancel this one. So A equals 3 over square root of 3. Let us rationalize. So this is 3 square root of 3 over 3. Let us cancel this one. So the value of A is square root of 3, or 1 square root of 3. So this is square root of 3. And to find the measure of side C, which is opposite to 90 degrees, C equals A square, or 2A rather. So this is 2 times square root of 3. So this is the measure of side C. So this side. And then let us have this one. So C equals 2A. The value of side C is 6 and 2A. So divide both sides by 2. So A is 3. So this one is 3. So let us find side B, which is opposite to 60 degrees. So B is A square root of 3. So the measure of side B, that is 3 square root of 3. So as you can see in our given, AD, that is AE, and ED. So the measure of AD, so this side, that is 3 square root of 3. And then AE, so we are going to represent this one as X. And AD, or ED rather, that is square root of 3. So let us move this one on the other side. So 3 square root of 3 minus square root of 3 equals AE, or X. So the measure of side AE, that is 2 square root of 3. So let us have now, so this side, that is 2 square root of 3, and this side, that is 2 square root of 3. So the perimeter of triangle ABE, that is 6 plus 2 square root of 3 plus 2 square root of 3, that is 6 plus 4 square root of 3. So this will be our answer. On number 3, find all possible values of the real constant k if the graph of y equals 2x squared minus the quantity of 2k plus 5x plus quantity of 4k plus 2 touches the x-axis at exactly 1 point. So to find all possible values of the real constant k, let us identify the value of a, b, and c. So the value of a, that is 2. The value of b, that is negative quantity 2k plus 5. So let us simplify this one. This is negative 2k minus 5. And then c, that is 4k plus 2. Since we are talking about k, let us use the formula for k. That is c minus b squared over 4a equals 0. So let us have the value of c, that is 4k plus 2 minus b, that is negative 2k minus 5 square over 4 times the value of a, that is 2, equals 0. So let us simplify. Let us write 4k plus 2 minus, we have a square of binomial, negative 2k multiplied by itself, that is 4k square, negative 2k times negative 5, that is positive 10k, multiplied by the constant 2, that is 20k. Negative 5 multiplied by itself, that is 25, all over 8 equals 0. So let us multiply the whole equation by 8. So 8 times 4k, that is 32k. And then 8 times 2, that is 16. And then let us distribute the negative sign. So we have negative 4k squared minus 20k minus 25 equals 0. So let us combine like terms. So let us write negative 4k squared and then 32k minus 20k, that is positive 12k, and 16 minus 25, that is negative 9, equals 0. So let us write again negative 4k squared plus 12k minus 9 equals 0. So let us multiply this one by negative 1. So this will be 4k squared minus 12k plus 9 equals 0. So let us find the factors of this equation. So if you are going to factor this one, so this will be 2k minus 3 and 2k minus 3 because we have a perfect square trinomial. So therefore, the value of k is 2k minus 3 equals 0. So let us move 3 on the other side. So 2k equals 3. Divide both sides by 2. So the value of k, that is 3 over 2. And this will be our answer. On number 4, in a trapezoid, the midline, which is the line through the non-parallel side, intersect the diagonal at P and Q. Find PQ if the parallel side have length 6 and 20. So this question makes difficult because it's very hard for the students to illustrate the given figure. But if we are going to illustrate this one, we are going to have trapezoid. So let us name the trapezoid as A, B, C, and D. And let us have a diagonal. So this is P and Q. So we are looking for this side. So let's say, for example, if the parallel side have length 6 and 20, so this is 6 and 20. So to find the measure of PQ, so PQ is DC minus AB over 2. So this will be 20 minus 6 over 2. So this will be 14 over 2. So the measure of PQ is 7 units. So this will be our answer. On number 5, list down all the roots of square root of 3x plus 19 equals square root of x plus 21 minus 2. So let us rewrite the given. So we have here 3x plus 19 equals square root of x plus 21 minus 2. So let us square both sides of the equation. So let us cancel this one. So this will be 3x plus 19. So we have a square root of binomial. Square root of x plus 21 multiplied by itself, that is x plus 21. And then square root of x plus 21 times negative 2 multiplied by the constant 2, that is negative 4 times square root of x plus 21. And then negative 2 multiplied by itself, that is 4. So let us simplify. Let us write 3x plus 19. We have x, 21 plus 4 is 25. Minus 4 square root of x plus 21. And then let us move x plus 25 on the other side. It will be 3x minus x plus 19 minus 25 equals negative 4 square root of x plus 21. So let us have 3x minus x, that is 2x. And then 19 minus 25, that is negative 6, equals negative 4 square root of x plus 21. And then let us square both sides of the equation to eliminate the radical sign. So let us have the square of binomial. 2x multiplied by itself, that is 4x squared. 2x multiplied by negative 6, that is negative 12x times the constant 2, that is negative 24x. And negative 6 multiplied by itself, that is 36. And then we have negative 4 multiplied by itself, that is 16 times x plus 21. So let us have 4x squared minus 24x plus 36. Let us distribute 16. So we have 16x. 16 times 21, that is 336. So let us have 4x squared. Let us move this one on the other side. Negative 24x minus 16x plus 36 minus 336 equals 0. So let us combine like terms. So let us have 4x squared and then negative 24x minus 16x, that is negative 40x, and then 36 minus 336, that is negative 300, equals 0. So let us write this one as 4x squared minus 4x minus 300 equals 0. So let us minimize our equation by dividing by 4. So this will be x squared minus 10x minus 75 equals 0. So let us find the factors of this equation. So this will be x and x. And what are the two numbers? If we multiply, we can get negative 75. And if we add, we can get negative 10. So this is positive 5 and negative 15. So let us equate to 0. So x plus 5 equal to 0. X minus 15 equal to 0. So x is negative 5 and x is 15. So let us check first if negative 5 and 15 is part of the solution. So if we are going to substitute negative 5 here, so this is 3 times negative 5, that is negative 15 plus 19, that is 4. The square root of 4 is 2. And then negative 5 plus 21, that is 16. Square root of 16 is 4 minus 2, so 2. So therefore, negative 5 is part of the solution. What about 15? So 15 times 3, that is 45, plus 19, 64. Square root of 64 is 8. And then 15 plus 21, that is 36. And square root of 36 is 6 minus 2. So this is 8 equals 4. So therefore, 15 is not included in our solution. So our answer is negative 5. So this will be our answer. On number 6, triangle ABC has a right angle at A. Let D be the foot of the altitude from A to BC. Let E be the foot of the perpendicular from D to AC. If AB equals 13 and BD equals 5, find DE. So let us illustrate the given triangle. So let us have triangle ABC. We have B, A, C. So angle A is a right angle. At the same time, D be the foot of the altitude from A to BC. So this is D. So this is right angle. And then let D be the foot of the perpendicular from D to AC. So this is E. So let us have AB, that is 13. And then BD, that is 5. So this is 13, 5, and 12 triangle. So the measure of this one is 12 because of Pythagorean triples. 13, 12, and 5 is Pythagorean triples. So to find the measure of DC, let us have DC as x. And we have 12 square equals 5 times x. And then after that, 12 square, that is 144, equals 5x. Divide both sides by 5. Let us cancel this one. So x is 144 over 5. Now, if you are going to find the measure of BC, BC is 5 plus 144 over 5. So this is 25 plus 144 over 5. So BC is 169 over 5. So this is the measure of BC. And this is the measure of DC. Okay. So after this one, let us have triangle BEC. AC. So this is 13 and this is 169 over 5. And then let us have triangle DEC. So DC, that is 144 over 5. And we are looking for DE. So to find DE, let us have BA, which is corresponding to DE. And then we have BC, which is corresponding to DC. So BA is 13, DC is 169 over 5, and then DE is X, and DC is 144 over 5. So let us cancel this one. So 13 and 169 are divisible. So 13 becomes 1, 169 becomes 13. So we have now 1 over 13 equals X over 144. So to find the value of X, we have 13X equals 144. Divide both sides by 13. So the value of X is 144 over 13. So this is the measure of DE. And this will be our answer. So I hope you will learn from this video. Thank you so much for watching, and God bless us all.